5, 4, 3, 2, 1, 0. All engine running. Liftoff.
Hey everyone, welcome to another episode of the Space Business Podcast, where we investigate all the exciting ways in which people participate in the new space economy by conversations with entrepreneurs, executives, investors, and other members of the space family. I'm Raphael Roettgen, and I'm an investor in and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. Sadly, I am not a rocket scientist, but I am an alumnus of the International Space University, which is also our partner in the podcast. Here's a short message from them.
The International Space University, founded in 1987 in Massachusetts, USA, and now headquartered in Strasbourg, France, is the world's premier international space education institution. It is supported by major space agencies and aerospace organizations. ISU offers the Master of Science in Space Studies program at its central campus in Strasbourg. ISU also conducts the highly acclaimed 2-month Space Studies program at different host institutions in locations spanning the globe, and more recently implemented the Executive Space Course, the Southern Hemisphere Space Studies program, and Commercial Space program. ISU programs are delivered by over 100 ISU faculty members in concert with invited industry and agency experts from institutions around the world. Since its founding, 33 years ago, more than 4,800 students and participants from over 100 countries graduated from ISU. Follow us on social media at ISUNet.
Our guest on this episode is Vytenis Buzas, the CEO and co-founder of NanoAvionics, a satellite manufacturer originally from Lithuania. These days they are present in other locations, like the UK and the US. If you have an idea for a space business that requires your own satellites, nowadays, in most cases, it doesn't really make sense to build the satellites yourself. Rather, you outsource that part to a professional satellite integrator like NanoAvionics. We will hear all about it in this episode. Please enjoy my conversation with Vytenis. So hi, we are here today with Vytenis from NanoAvionics. Hi Vytenis, welcome to the podcast. It's a pleasure to have you here. Where are you joining us from today?
Hi, hello everyone. It's a pleasure for me to share about our activities. Today I am in Vilnius, Lithuania.
That is where the company is originally from, if I remember correctly.
Yes, this is correct. The company was originated in Vilnius 5 years ago in 2014. So most of the people are working from here. Yeah, and I think later we will discuss where are our other locations around the world, right?
Exactly. I'm looking forward to that because you guys have expanded, which is great. So now, as I understand it, so NanoAvionics, I'm very happy to have you guys on because you're the first company I have on, which is building satellites, which is very exciting. It's obviously a very important part of the space ecosystem. Now, keeping in mind that some of our audience are not deep space experts, when people think about building satellites, often they think about just like, big aerospace companies like Airbus or Lockheed building very big satellites, very expensive satellites. Right. And I think that's a little bit different in NanoAvionics' case. So you want to give us sort of the summary of what the company is doing?
Yes, of course. You're right. We are a little bit different. The companies you mentioned are so-called old space companies, big companies. They are following rather classical understanding of what is satellite, and in our minds, let's say in regular minds, I mean, as we understand, the satellite is like a big thing, like a car. The weight is like more than 2 tons or something. A very expensive machine, etc. Yes, this is the old space, and our company is following so-called new space philosophy. New space philosophy is a different understanding what is satellite. And in new space world, the satellite is small, robust, agile, easy to build fast, and relatively, well, maybe cheap is not the right word, but optimal cost. And in our case, we're building satellites which are, I don't know, maybe 100 times smaller than the Airbus or Boeing satellites. And our task is to launch a lot of them. I mean, tens or even hundreds of them. And we are helping our customers to do so. One of the key things is, as I mentioned, that the satellites we are building are small. So let's say 10 to 50 kilograms per satellite. And the essence is to launch the quantity of them, the big quantity of them. So we have better coverage, we have real-time coverage, I mean covering entire globe of the Earth. So this is so-called new space, and the industry and this concept is relatively young. It was invented roughly 15 years ago, and we're very happy that we have discovered a few novel things, a few innovative things, how to enter this market, how to go into this market, and we offered some, let's say, innovative things, how to make those small satellites, those nano satellites, closer to their bigger counterparts in terms of functionality and reliability. Because I mean, we don't have to forget that our customers are demanding, and they want pretty serious onboard resources. I mean, electric power resources, communication resources, and let's say volume for their payload, so they can be sure that they can do business based on that constellation, on that big number of nano satellites we're building.
And just to unpack this a little bit, so if I understand it correctly, you guys would basically do everything probably except the final payload of the customer. So like except the communications radio if it's a satellite communications company, or the sensors if it's an Earth observation company. Is that correct?
Yes, this is correct. I could give you an example. From this perspective, from the business perspective, we are airplane manufacturer, like regular airliner manufacturer. I mean, at this point, none of the contemporary airliners manufacturers like Boeing, like Airbus, they are not taking care about the transportation. I mean, transportation of the passengers, transportation of the cargo, etc. They sell their product, they sell their airplanes to those guys who are running the airlines. For example, to SAS, to Lufthansa, to Finnair, to Delta, etc. So from this perspective, we are exactly like those guys, but we are building satellites, and we are selling those satellites as a vehicles to those guys who want to do business based on them. And for that reason, they are building the payloads themselves. And the payload, the variety of the payloads are pretty broad, starting with Earth observation and finishing with telecommunication, scientific payloads, fundamental research, etc. So yes, we are not building the payloads, but we are building nano satellites as vehicles.
So if I can expand on your analogy to the airframe builders like Boeing or Airbus. Now, yes. With Boeing or Airbus, actually, one thing is that at least these days, many of the components of the aircraft would actually come from third parties. So like the engines would come from like Rolls-Royce or Pratt & Whitney. How is that with you guys? Do you guys source external components as well, or do you actually build most of the subsystems or any of the subsystems in-house?
The model is has some similarities, actually. First of all, our company is a design bureau. I mean, we are doing a design. We do necessary research. Of course, we try to avoid as much as possible going into the research because, well, research institutions are having this task, this problem. So in our case, the research we do is rather how we will apply certain decisions, certain technologies. But yes, so let's say we create the design, then we outsource manufacturing. In some cases, yes, we are purchasing thrusters, for example. In other words, rocket engines, small rocket engines to propel the satellites if needed. We buy some communication subsystems. We buy, for example, solar cells, and from those solar cells we assemble solar arrays. So I should say that quite a significant part of the subcomponents are being bought from the third parties. Then we are doing integration in-house. I mean, we purchase those parts. They're being manufactured by the third parties. Then those parts are coming back home to us. We assemble them, we integrate them, and then we do functional testing. After functional testing, of course, we do all of the necessary testing campaign, environmental testing, thermal vacuum, etc., etc. So yes, I mean, to answer your question, I can say that yes, we have some similarities because significant part of the components is being purchased from the third parties.
And in terms of integrating various types of components, I mean, these days, how much flexibility really exists? And what I mean by that is, for example, on one end, I guess a sort of very ambitious end, sometime in the future, I guess we could have something that could be something like let's call it a fully modular satellite, right? Where you just have the basic bus and then you plug in whatever subsystem from whatever supplier exists, and it kind of automatically fits and interconnects correctly. But I assume we're nowhere near that. So how is the situation at the moment?
Well, actually, this is a very interesting angle you just touched, and this is one of key aspects distinguishing us from our competitors. We want to see ourselves there. I mean, we want to see ourselves there where we have, let's say, at least the basic hardware standard, where we have at least the basic software standard, and we tweak something accordingly to the variation of different payloads. But our goal is to have a baseline as standard as possible, because we believe in that so-called new space approach, where we have a lot of satellites flying in orbit, where they are something similar to the mobile phone we have today. And actually, we are now doing some experiments similar to the applications of the mobile phone, and where, let's say, of course, all of our customers are unique. They have unique instruments, unique payloads, and of course, we want to simplify the process of integrating those different payloads into our buses, and to make it more cost effective. For that reason, actually, we are now doing some experiments with software applications where we have to tweak only a certain part of the software, but not the entire software of the satellite. So this is the approach we have. Of course, in the real world, it will never be standardized 100%. Something have to be changed always, because this is not only software, this is a huge part of hardware, and that hardware must work reliable, must be reliable, because the space environment is harsh. So of course, maybe we will not have in the future fully standardized buses, but significant part of the bus of the vehicle will be standard, and we will be tweaking less and less hardware and software to accommodate different different payloads.
And on the component side, do you see any sort of exciting changes, any exciting new technologies? I think many times when we think of satellites, we think that sort of the non-payload parts, haven't changed that much, that they've been around for a long time. For example, you mentioned thrusters. And so I guess, typically it's either some sort of chemical thruster with hydrazine or something like that, or an electrical thruster, which is a, Hall effect thruster, which also has been around for a long time. But that's just as an example. Do you see anything that's changing in basic satellite design?
Well, actually, a lot of things are changing, and I believe that our company contributes to those changes. But I think the most exciting thing is general maturity and complexity of the global technology of the electronics and mechanics. I mean, I started to dig into this business like 11 years ago. It was around 2009. So by then, I mean, I remember what kind of microcontrollers we were able to choose for space applications. I mean, like I have in mind those industrial ones. I mean, not let's say classical old space, really complex and really expensive microcontrollers, but I'm talking here about the industrial grade, automotive grade, for example, microcontrollers. And through those last 11 years, they changed dramatically. And I mean, functionality, integrity, reliability changed dramatically. And this is a really good thing for us, for companies like ours, and for NanoAvionics in particular, because having the same volume, we can do much more than ever before. I mean, from the perspective of functionality, from the computational power on board, from having the same volume, we have like many times more functional and more powerful electronics. They are getting more and more power efficient, actually. And well, it's a really exciting thing. I mean, because those small satellites, those CubeSats, as they were called before, few years ago, they can now, in some cases, they can compete with bigger satellites, with 100 or 200 kilogram platforms. Of course, it's not there yet, but it's coming. I mean, and the general let's say evolution of the technologies of the electronics is helping us to build more and more competitive nano satellites.
And that's the famous trend of the miniaturization of components that you're mentioning, which, as you say, of course, is very important because it allows you to have more capability or the same capability in a much smaller space, and also, I suppose, for less weight. And weight, of course, equals cost because of the launches. So building on that, while we're speaking about satellite size, what are the kind of typical sizes of satellites, satellite buses you guys are manufacturing? And you mentioned the CubeSat standard, and for people who are listening who may not know, so that's something that I think was developed about 10 years ago by a couple of professors in the US. And basically a CubeSat, and the measure here being 1U, is a cube with side length of 10 centimeters.
Yes, that's correct. This standard called CubeSat was invented, like, I think now it's even a bit more than 10 years ago, but it's around that. And it was invented to make the space access for students, for higher grade students, easier. So if you standardize something, I mean, you define certain rules, and people around the world start to follow those rules, and launch providers can start follow those rules, and it's much easier to access the space. It's much easier to integrate, let's say, that small satellite called CubeSat with a launch vehicle, and someday the price starts to go down. So yes, we joined that club a couple of years ago, and we found that following this trend is really convenient from some perspective, but our goal was to make the hardware much more functional. So I mean, something like beyond the CubeSat, something beyond the university, let's say, students' educational experiment. We wanted to pump the muscle, in other words, of that CubeSat, so it could be aligned with demanding requirements of commercial customers. And this was our goal. And let's say we follow that standard shape. So we combine our nano satellites out of those cubes, roughly telling. So today, the main workhorse we have is 6 units. 6 units means that we have 6 cubes combining the satellite bus. So the dimensions are roughly 10 by 20 by 30 centimeters. But also we have a few options of a bit bigger nano satellites. So now we have 6, 12, and 16 units. And the mass range of those 3 main products we have is starting with 6 kilograms and finishing with roughly 25, something like this.
And this 6 unit size would be, if I'm not mistaken, a relatively typical size for Earth observation applications, for example.
6 units in some cases, of course, might be a bit too small, but 12 or 16 units is I mean, it unlocks really nice capabilities for Earth observation. And now we have a few missions, a few serious missions where people are using 12 or 16 units, and they can put there inside really nice optics. So, for example, 16 units, the size of 16 units is roughly 20 by 20 by 40 centimeters. And it's really unlocks really nice capabilities, actually.
And that would weigh about 20, 25 kilograms, a 16U unit?
Yes, 20, 25 roughly. It may go up to 30 in some cases. I mean, but this is a rough estimation of how heavy it could be.
And then I know this is not an easy question, but sort of on average, excluding the payload, what would a 16U bus like that cost?
Roughly a few €100,000.
Okay. And then I suppose if we were talking, let's say 20 kilograms, and the current advertised rideshare price on the SpaceX Falcon is $5,000 a kilogram, so that'd be like another $100,000 or a little bit more for the launch. Okay, so you're talking basically a few €100,000 in total, maybe €500,000.
And this is a really nice thing, actually. Another aspect which is driving this market really positive. The prices of the launch. If, let's say, 10 years ago, you couldn't, let's say, plan to launch the CubeSat or I don't know, maybe 2 or 3 units CubeSat, paying less than €250,000. So now, I mean, for the same price, you can launch 12 or 16 units satellite. So this is a really, really strong driver for the market, really strong and positive driver, because the access is getting easier, and at the same time it is getting much, much cheaper, which is really important for people who want to do business and who want to make sure that they will have positive return on their investment.
Absolutely. And then, so the next question would be, what kind of customers you guys have? I mean, we already mentioned some of them, like, the Earth observation, but sort of what big groups of customers do you see?
I think there are some, we can see now some segmentation between the groups of the customers. I would say a huge group around 70% is telecommunication related. Of course, telecommunication, under telecommunication, we have those magical words IoT, Internet of Things, and M2M, machine-to-machine communication. So roughly telling, they belong to the same group, telecommunication. Then we have around 20% Earth observation, and roughly remaining 10% in orbit demonstration, technological or scientific missions.
Okay. And if you kind of think across the board of the customers that you have or you have seen, or that companies that may have approached you with certain use cases in space, has there been anything that you were really excited about, that you thought was really cool?
Well, I could say that me personally, I'm really excited about all of the customers we have. I really appreciate that serious customers are coming, and they trust us. They trust that they can build their business on the buses we build, and I'm really happy about that. So I'm talking seriously. All of those guys are really important for us, and really big companies are coming, and companies, institutions, actually, even space agencies around the globe, and I'm really excited. And let's say every single customer is unique, and every single customer has really unique requirements and brings really interesting engineering tasks, engineering problems to solve. I mean, to accommodate, to customize the bus a little bit. And of course, mission requirements are different, the different orbits, etc. So it's, honestly, all of the customers makes our days to be really exciting.
Yes, and of course we're grateful for having all of these different space entrepreneurs building up the space ecosystem. So I think, though, most of the applications we've been talking about so far, they are probably substantially all focused in what's called low Earth orbit. Have you guys ever done anything beyond low Earth orbit, like for example, like a science mission in deep space or anything like that?
Yeah, through the history, we had a couple of really interesting requests. We were talking about lunar missions, lunar flyby missions. We were running a few studies. Also, we were running a few studies based on GTO and GEO orbits. Also, we were involved, but not really, significantly into deep space missions. But in the near future, I think we will have a few things flying into GTO at least. Of course, environment there is really different. The good thing is our hardware. When we were back in the days when we were designing our hardware, we were thinking that one day someone will come and ask us to go beyond lower Earth orbit. And we see that day is coming, actually, and we are getting ready for that. And yes, some really exciting missions are coming. Of course, going to GTO to GEO, for example, are rather scientific missions than commercial, because most of the commercial missions are now focused towards LEO, up to 800 kilometers of altitude. But yeah, there are a few really interesting things which are coming.
As you mentioned, and that's part of the reason I asked the question, the environment, the further out you go, gets very different, especially once you go outside of the Van Allen belts and basically the protective magnetosphere of the Earth, when I suppose you will probably need very different type of equipment that's, for example, radiation hardened in some cases. So is that something that you guys have looked at, or where do you think the status of that is?
Yeah, so today our hardware is so-called, falls under the group which is called radiation tolerant. Of course, if you go above Van Allen belts, you have to have different type of the hardware, which is called radiation hard. So at this point, we have a few, let's say, well, clever or smart ways how we can solve, or how we can go with the hardware we are using now day to day. But of course, some of the things must to be changed because radiation environment is different, magnetic environment is different, so attitude control system, navigation is different there, going much higher. So yeah, but this is a really niche thing, and we are getting ready. We are, let's say, we are getting ready to have a couple of those interesting missions.
Cool. And so if you kind of look across the board of the customers you have right now, what's in the pipeline, what you guys think will come into the pipeline in the future, where do you see the satellite market at large going? Because there's obviously all of these, different projections out there. And let's leave aside the mega constellations like, the Starlink, SpaceX, and Amazon Kuiper for the moment, because they're obviously doing their things in-house. Where do you see the rest of the market going, for example, in terms of the size? Is it like the 6 to 16 you guys are focusing on? And also, do you guys have a sense of like rough numbers, like how many thousands or tens of thousands of satellites we might get to like in the next few years?
I'm 100% certain that future satellite will be small and it will be hyper functional and hyper powerful. The question when, it's really difficult to answer, because for the last years we saw that some of the predictions were too early. Some of them, the timing was a bit maybe too late. But the general trend, general paradigm is shifting towards reducing the size and increasing the complexity and increasing the functionality and reliability. So this is 100% certain. When it will happen, this is a really serious question, because many economic factors are driving this question, technological factors are driving this question. Still, many things must to be developed, and development requires time and money. I mean, you have to fuel the progress, and it will take time, because back in the days we wanted to do something unique, to distinguish ourselves among our respected competitors, actually, because there are quite a few of the companies which made a really great job like 10 years ago or something. And actually, we were learning from them. Maybe we were customers of those companies back in the days. But now the reality is changing, and the future, first step into that future is here. It's coming, and we are now talking, as you mentioned, about the mega constellations, etc. But the next step, it might take 10 years. I mean, maybe, I don't know. But the satellites are decreasing in their size, but increasing in their functionality and in their capabilities. So this is the general thing, what is happening right now. And for example, our company is one of those companies, or let's say, which is really strongly pursue towards let's say these two critical aspects. I mean, decreasing size and increasing capabilities.
Understood. And as we have mentioned, and it sounds like you agree, still within a certain time frame, we expect those numbers of the satellites, the absolute number especially in North orbit, to grow quite dramatically. And there's actually an increasing concern, of course, about space debris and the dangers from space debris. Is that something you guys are also thinking internally about? And for example, has that also had already repercussions in satellite design? I don't know, for example, are people now using more propulsion, where historically they would have not necessarily like put in a propulsion unit, or is there other modifications in satellite design because of space debris?
Yes. Also, yes. To answer your question, I mean, even judging from our pipeline, if all of our customers will turn to be successful in the upcoming future, I don't know, maybe 2 or 3 years. So I think our company alone, theoretically, of course, will need to build thousands of the nano satellites. Of course, this is theory. I mean, but the reality will be different. Maybe, I mean, if it will be like a few hundreds of satellites, I think we will do a nice business, and we will be able to consider these upcoming years as a really, really successful years. But talking about the space debris problem and question, let's say tools to solve this problem are also here. And some of our customers, for example, require to have a functionality of deorbiting, and we can do deorbiting in a various ways. So let's say 2 most popular ways is propulsion system. So the thruster, electric, chemical, cold gas, or other types of let's say device which can propel the nano satellite. And the second device, let's say, which is also becoming really popular, is huge deployable sails. So yeah, these devices can help to deorbit the satellite, and in some cases, of course, it depends on the mission requirements and on the available volume on the satellite. We can choose, let's say, 2 of these options. And there are, if let's say, we could also discuss more broadly, but there are some also quite a number of other devices who could help to perform controlled reentry or deorbiting of the satellite after let's say it finished its mission.
Sure, I guess also the tethers and all sorts of things,
yeah.
But that's for a separate episode. That's a whole episode by itself, the space debris discussion, I suppose. But you reminded me of a couple of questions I wanted to ask when you were mentioning your pipeline. So one thing I forgot to ask is, I asked you about the price, but I didn't ask about the time frame. So if I have a good idea for, let's say, an Earth observation concept now, and I know where I'm getting the payload from, or the payload is even ready, it's like, how quickly can you get a satellite ready?
Yes, and there are here a couple of aspects. Let's say satellite alone, as a piece of hardware, as a device, we could build like I think in a couple of months, 2 months, like 6 weeks or 8 weeks, something like that. If we're talking about the standard bus, but we have quite a number of aspects around that satellite as a device, as a piece of hardware. We have frequencies regulation. We have to file for the frequencies. We have to get the permission to use the frequencies in orbit. Then we have to agree with the launch provider when and from where we are going to launch that satellite. Then if we are taking into equation some certain orbital parameters, so we are narrowing down our windows of opportunity to launch the satellite as soon as possible. Because let's say if we need to go into some specific orbit, if it's not like, well, most popular orbits like low inclination, I mean ISS orbit, International Space Station orbit, or sun-synchronous orbit. If we have to go somewhere in between, it will take us time to accommodate that launch. Then, of course, let's say we assume that your payload is ready. So we have to integrate your payload with a bus, with a satellite. We have to run qualification testing and acceptance testing. So it will take us couple of weeks more. So from the realistic perspective, of course, yeah, I forgot. Then we have to set up a ground station network, or you're okay maybe with just a single ground station somewhere in your location or in our. So having these all of these parameters together, realistically, we will need around 12 months from the day we sign the contract until the day the satellite is in orbit. But I'm here talking a bit optimistically, but it's, let's say, it's pretty realistic. I mean, realistically optimistic. So let's say it will require 12 months, roughly.
You mentioned some parts of the mission there, like booking the launch and setting up ground stations. Is that something you guys actually would get involved in, or did you just mention that as part of the general process?
Yes, this is a part of what we do. NanoAvionics was started as a supplier of the components, but very soon we realized that it's too late for us to step into this market as a supplier of the components, because our colleagues were there already with a very nice products. So we started to think how we can distinguish ourselves from those guys in order to do a successful business. And we decided to narrow down our activities and to integrate them vertically. So we build the bus, we integrate the payload, we arrange the frequencies, or at least we help with international organizations which are responsible for frequencies regulation. Then we help our customers to arrange a launch vehicle, or we are taking care ourselves. Then we integrate the satellite with the launch vehicle, and finally we commission the satellite once it is in orbit. And then we agree with our customer whether our customer wants to use his own ground stations, or he wants to use our ground stations, or he wants to be compatible with one of the commercial ground station networks. For example, our partner KSAT, which has really nice network around the globe. Our satellites are compatible with that commercial ground station network. So you can have, really nice near real-time and near global coverage ground station network. So which is important for any commercial customer. So yes, to answer this question shortly, we can help with a lot of things, but most of them are related with logistics, with formal things. And from the hardware perspective, we build one product which is, let's say, easy to realize, easy to understand. This is a satellite bus. We can help with components, we can help with even maybe sometimes with a payload, but our workhorse is a 6-unit bus, 12-unit and 16-unit buses. And we help with all of the logistics which are around that satellite until it gets into the orbit, fully operational and working. So this is, let's say, roughly the model of what we're doing.
Cool. And the last question I wanted to ask you about sort of the general topic of customers and services. We're still recording this in the time of coronavirus and COVID. Have you guys seen any tangible impacts of that? For example, in terms of, I don't know, like delayed orders, things like that?
We had some delays, but those were not really significant, because the period, let's say the business time frame, the business period since we signed the contract until we delivered the bus and we integrate it with a customer's payload is relatively long. And yes, we had a few months of uncertainties, maybe even a couple of weeks of small global chaos. But so far we are very happy that we don't feel the impact. Maybe we don't feel it yet because our business period is relatively long. I mean, it's not like one week turnover. I mean, we sign the contract, we deliver the product, we get, let's say, we get the payments, etc. The customer is happy, or we have to adjust something, or we have to fix something. It's not like 1 week period. It's like 1 year period. So, in this scale, those couple of months, maybe it's too short period for us to feel the impact yet. Maybe we will feel it a bit later. But from what we have right now, I can say that we're very happy because, I mean, we were accelerating our activities. We even expanded our company a little bit. We hired around 7 new people during this period. So, I mean, also we signed a few new contracts with quite a serious customers for relatively big programs. So in general, I'm happy. So far, everything seems to be really nice and good. But of course, we have to be careful. We have to be aware of the potential bumps we can have in the midterm. So yeah,
That makes sense. Let's change tack a little bit. So one sort of general macro question I wanted to ask you is, if we all agree that in the future there's going to be much larger numbers of satellites. Again, we started this call, describing how historically satellites, were very big. There actually were not a lot of them being manufactured. It was almost sort of like one by one manufacturing.
Yeah.
And clearly the sector is now moving towards something that's almost like, like a production line, continuous manufacturing. I mean, certainly the large constellations like Starlink. Now, if you look at other high-tech products, they're being manufactured mostly in certain locations, low-cost countries like Taiwan, highly automated. It doesn't seem like we have reached that status yet with satellites, but do you think that's where we're going?
Let's say satellites for most of our customers are being built around European Union as today. Let's say majority of them. We also expanded into United States, into United Kingdom. But let's say now, as of today, we build most of our satellites in European Union because most of our customers geographically located, geographically closer to European Union than, for example, the United States. What we've done, actually, we applied a lot of rules, how we manufacture, how we control the quality, the rules which are coming from automotive industry. And let's say our guys, from the design perspective, I mean, design engineering staff is coming from the aerospace industry, but manufacturing staff, logistics staff is coming from the automotive industry and mobile industry. So it's combining all of these things together gives a really interesting picture. But from our perspective, from how we organize our logistics and our business, I should say that it's not, let's say, time to have too much of manufacturing equipment in-house. We can hire guys who are manufacturing parts. I mean, millions of pieces of parts per month or per year, or even maybe per week. So we can have most of the advantage combining the experience those guys are having. Also, we have a context of, relatively not really huge quantities of subcomponents or buses to be manufactured, let's say, per 1 year. And then we still have a very nice combination of the fixed expenses. I mean, fixed expenses for running that manufacturing machinery. So, I mean, we follow industrial rules, mass manufacturing rules, quality control, etc., we were working quite a lot actually to eliminate human factor out of that manufacturing chain. I should say that we are pretty strongly automated company from this perspective. But pretty strongly automated, but at the same time, quality control and mostly quality control is really strict because, you cannot fix it once you launch the satellite to orbit. So I should say that we are significantly automated company.
Cool. And to bring it back from the general industry towards NanoAvionics, you mentioned already you're a few years old. You started in Lithuania, but now you have several locations. So where are you guys now?
Yeah, so we have now 2 locations in the United States. Our investor, AST and Science, is located in Texas. So we have a location there, and also, let's say, sales and engineering support office is located in St. Louis. Also, we have an office in the United Kingdom. It is located in the Harwell campus. So these are, let's say, main locations of NanoAvionics. And of course, today the most of the brain power is concentrated in Lithuania, Vilnius.
Okay, and so a couple of questions following from that. Are you currently hiring at any of those locations?
All of them. In all of them, we are hiring people currently.
That's great to hear in the current environment. So I assume people can go to your website and the jobs are probably listed there, right?
Yes, exactly.
Cool. And then the other follow-up question is, which I was going to ask you anyway, you mentioned your strategic investor, AST and Science. They've obviously been quite prominently in the news themselves recently because they received a very sizable, I think, $100 million financing round, substantially to execute on Space Mobile, which is a service that basically allows regular mobile handsets to communicate via satellites. So how did that original deal, I think it was in 2018, how did you originally get together with AST and Science? What was the rationale there, and how are you guys working together now?
So actually, the guy who approached us was Abel Avellan himself. I think it was 2017 something, and we've got an email from him, and then we had a really long and nice conversation by phone. AST was incorporated by then, and they were looking for a relatively young, still a bit smaller, but high potential nano satellite company to incorporate into the entire group, because those guys were having plans, as they revealed now, as you mentioned, about the Space Mobile, etc. So that was really interesting conversation. We were working by then with regular business as we have today. Of course, by then it was much earlier stage, and Bell came with other guys from AST and Science, and we had a really constructive conversation. And they decided to do an investment into NanoAvionics, and of course, from the company from Europe, to have a partner, relatively big partner from United States, it is really important in order to be capable to enter US market, because US market is a really big market. It's mature market. The customer, let's say the standard customer, is really very well educated and demanding. So that helped us a lot, and we're really happy that that day came, and we were able to find a very nice way for our collaboration.
Great. And so following on from that, if you were to look like, I don't know, 5, 10 years in the future, what's your vision of the company? What do you want NanoAvionics to look like going forward?
Yeah, so if we look forward, we see ourselves, our ambition is nano satellite world leader, and we will be working with our current customers, and quite a few of them will turn into those mega constellations. So from one perspective, the future or the future roadmap seems to be pretty clear, because we have all of the necessary components, which are now working as a fundamentals for our future today. And yeah, 10 years perspective is a really from one perspective is a long time. From another perspective, it's well, it will pass really fast. But personally, I'm very excited to see what technologies will be invented generally within those 10 years, and what technologies we will be able to apply for the satellites. And I have no doubt the future is really bright, interesting, and the business will bring really nice results.
That ties nicely into my last question,
Okay.
which I always ask. So if you weren't doing NanoAvionics, but assuming you're still generally excited about the space sector, is there something specific, some specific opportunity you would pursue? And for example, it could be something like a space application that you think people are doing, but that none of your customers are doing so far.
Actually, back in the days, of course, with our early investors, we were discussing and we were planning what other directions we could take. I should say I'm very happy that we decided to go into this business, but not into application business or other kind of the business, because as we have a small joke today, business based on nano satellites we could compare with the gold rush, and in that gold rush, NanoAvionics is a company who is building picks and shuffles. So our business line is certain, and it's certain that we will benefit from that gold rush. So I'm really happy that we decided much more than 5 years ago, we decided to go into this direction.
Excellent. And then the final question, which I always ask is, do you like science fiction? And if yes, what are your favorite books or movies or TV shows?
Well, the answer to this question is obvious: Star Wars. So actually, Star Wars is a part of our culture. Of course, recent years we had new releases of new series of the Star Wars around the Christmas time. So the day when new Star Wars movies being released is like day off for the entire company, and we go to the cinema to watch the movie and to have dinner, actually. So I mean, this is the ultimate winner for myself when talking about the science fiction. But let's say if talking from the broader perspective, I'm a fan from the young days of any kind of the movies related with space exploration. I mean, interplanetary flights, etc. But from the book's perspective, last year's my favorite books are rather maybe not the science fiction or something similar to that, but books related with finances. I mean, it's kind of my hobby to to study the economy from some perspective. So I would say, yeah, maybe it might look a bit strange from the hobby perspective or free time perspective, but yeah, my favorite books are related to financial markets and economic sciences, etc. Just to help. I mean, from some perspective, to help to predict what will happen in the future and where we have to drive our business.
I got to ask you: is your background engineering or business or something else?
My background is aerospace engineering and robotics, mechatronics.
Okay, so this is kind of a typical space founder background. So for me, who has a business and finance background and who invests in the space sector, I'm always very happy to hear when the engineering founders also take an interest in the business side, because that is, of course, very important. Vytenis, thank you so much for your time, and very exciting to hear about the company and also about Star Wars, and that you're having the Star Wars parties. I hope you guys are going to continue that forever, and maybe one day you guys can convince some customer to build like some satellite that looks like an X-Wing fighter or a TIE fighter or something like that.
Yeah.
Thanks.
Okay. Thank you very much for your interest. It is really interesting to have this kind of the discussions, and I'm really excited to have such a nice conversation with you.
That's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can also follow us on Twitter at podcast_space. Also consider supporting the podcast at www.patreon.com/Space Business Podcast. If you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or are interested in being a sponsor, or really anything else, drop us an email at spacebusinesspodcast@gmail.com. That's it. I look forward to seeing you for the next episode.